Hello everyone. Today we'll be solving the problem number 76, minimum window substring. So you can just go through the problem and you can try to understand the problem with the help of examples as well. They have clearly mentioned the examples here. So I'll just summarize the question so that it will be easier to understand. So what is our main task here? So let's see what the question states here. The task is to find the smallest substring in the string yes. This one, they have given the string yes here. We have to find the smallest substring in the string yes that contain all the characters from string t. So that has to contain all the characters from the string t, including duplicates. If no such substring exists, then we have to return an empty string. That's what they have given here. So that's what the problem states here. Again, I'm telling the task is to find the smallest substring in the string s that contains all the characters from string t, including the duplicates. This we have to keep in mind. Just keep in mind we can include the we have to include the duplicates as well if found. So if no such substring exists, then we have to return an empty array. So that's what we have to consider, right? So let's go with the example. Let's try to understand the examples they have mentioned here. So just give me a second here. So yeah, clearly you can see here one thing. They have given the string here yes, and they have given here a b c. The output will be b a n c. Why? Here you can clearly see the string they have given here is a b c t, and here either we can go with this one a b whatever they have given here a d o b e c. This is just for the reference here. ABC is found here, right? So this one also we can go, but the length here will be 6 basically. We will be performing same things actually for all this thing for every window. We'll be making use of the sliding window basically. So here you can clearly see this is the smallest substring B A N C. Within this substring we have the character A, we have the character B, and we have the character C as well. So this is the shortest substring with the characters, this one. Here they have clearly mentioned the minimum window substring B and C includes A, B, and C from the string C. This is fine. Same goes with the output. I mean example 2 as well. Here S they have given A, T they have given A. As there is only single character, the output will be A directly, right? So just give me a second here. So you can clearly see the empty string is S is the minimum window. So the output will be A here. Here the S is A. S consists of the A, character A, and here T consists of the character double A. We are displaying the empty string. Why? Here they have clearly mentioned in the explanation both A's from T must be included here, but this S consists of only one string, right? That is A. So while mentioning the question, I had said one thing here. We have to include the duplicates as well. So our main task is to find the smallest substring in the yes that contains all the characters from string T, including the duplicates. That's what I said during the question, right? So see here, we have the duplicate of A twice here. So, but we have only one string here in the S, nothing but single A. Both A's from the T must be included in the window. Since the largest window of S has only one A, we are returning the empty string in that case, right? So I hope the question is completely clear. First, we will discuss the approach, then we'll be discussing the edge case, and then finally we'll write the code and discuss the complexities. So let's discuss the approach step by step. So let me come here. Let me give here. Sorry. Let me give here approach. So we will be making use of the sliding window technique here. So we are going with the sliding window here. Let me quickly give here. We'll be making use of the sliding window here. Just keep this one in the mind. First thing is what we'll be doing here. We have to maintain the 2 pointers, right? So as we are going with the sliding window, first step here is we will be maintaining the 2 pointers. One is left and one is right here to define the current window. Basically, we are making use of this left and right pointers to define the current window here, right? This is the first step. Then what we will do, we'll make use of the hash map here along with this 2 pointers. We'll be making use of the hash map as well here. this one, we are just making use of the hash map to track the frequency of the characters in the current window. Why we are making use of the hash map here? To track frequency of current window. We'll be making use of the hash map. This is fine. This is easy, right? So, and we'll compare it with the frequency required by the T. So finally, after this, we'll be compare it with frequency required by T. So that's what we will be doing here. This is the first step. I hope this is clear. Next, let's move on to the next step. What we'll do, we will expand the right pointer to include more characters into the window. So we have left and right pointer. We will be expanding the right pointer. Why we have to expand the right pointer here? To include more characters into window. To include more characters into window. So I hope this is clear. So let's move on with the third step. Once the window contains all the characters from T, we will shrink the left pointer to find the minimum substring. Once the window contains, so here if window contains all the characters, then what we will do? We will shrink it, all the characters from T, right? Basically from T. This one is very important. If the window contains all the characters from the T, what we are doing? We are shrinking the window by using the left pointer. So we are shrinking, just shrink the window using left pointer. I'll just take this one using L, right? Left pointer to find minimum substring. So here find min substring, right? Yep. So once the window contains all the characters from T, we'll just shrink it using the left pointer to find the minimum substring. Finally, what we'll do, the fourth step is we will keep track of the minimum length and start index of the substring. We'll just keep track of the minimum length, keep track of minimum length. So that's what we'll be doing here. We'll be keeping track of the minimum length and start index of substring and start index of substring, right? This is what we'll be doing here. This is the approach that we'll be going with. So again, I'm telling, first step what we'll be doing, we'll be making use of the sliding window and the hash map. So 2 pointers, we'll just go with the 2 pointers left and right for the to keep track of the current window. Next, we'll be going with the hash map to track the frequency of the current window. We can clearly see here, right? Then we have to compare this one to find the frequency required by T. This is what we'll be doing in the first step. So second step, what we'll be doing here, we'll be expanding the right pointer to include more characters in the window here. This is important. We'll be expanding the right pointer to include more characters in the window. Once the window contains all the characters from T here, this one, once the window contains all the characters from T, we will be shrinking the window using the left pointer to find the minimum substrings. Finally, we will keep track of the minimum length and starting index of the substring. You will clearly understand this one while we start to write the code or while we write the code. So first, let's discuss one by one this one, edge cases one by one. Then let's write the code. I'll just explain the code while writing the code. So let's go with the edge cases one by one. Let me give here edge cases, right? So the first edge case here, we are going with the basic one. So the example one, so they have given here, you can clearly see here, BANC, right? The example string. So they have given this one. T, they have mentioned ABC. So this one, the shortest substring here containing all the characters from T is this one, BANC. We have discussed that one while explaining the example itself. I have explained this one. So the shortest substring containing all the characters from T is BANC. The output will be BANC, right? This one. This is basic one, right? So next, let's go with the second edge case, nothing but the exact match. So in my case, I'll just consider S equals A. Let me consider within the string a character A and T also. We are going with the exact match, right? T also A here. So the output will be here A as well. Why the output will be A here? Because the entire string is the answer here, right? We are just going with the exact match here. So the entire string is the answer. So this is for the exact match, right? This is fine. And let's go with the third edge case here. So the third edge case that we are going here is the third edge case that we are considering here is insufficient characters. While I say insufficient characters, let me consider the example. Within the string, I'll just take the character A. Within this one, for the T, I'll just consider the characters double A here. So the output will be here empty string. Why the output will be empty string here? Because T requires two A's here. This one, T, we are having two A's. So T requires two A's in S, right? But S has only one A here. So the output will be empty string. This is for insufficient characters, right? This is for the insufficient characters. So let's move on with the fourth edge case, nothing but the no match. So while I say no match, so I'll just consider the example here. Let me consider A, B, C, D, E, F within the strings, and also let me consider within the T, let me consider G and H here. This is fine. So the output will be here. This is G and H. The output will be here empty string. Why the output will be empty string here? None of the characters in the T are present in the S. You can clearly see here. Here we have the characters G and H in the T, but in the string S, we don't have any characters that are present in T. Either G is present or H is present here. G, H is not present right here. In simple terms, the characters G and H from T is not present in the S. So the output will be empty string here. So just give me a second. This is for the condition no match. This is fine. This is the fourth edge case. Let's move on with the final edge case, nothing but the fifth one. So fifth one, this is minimal match. While I say minimal match, let me consider the example here. Triple AB, and let me consider the characters here AB within the string T. This is fine. The output will be here AB. So the output will be AB here. You can clearly see here we have the string, we have the characters AB within T, and we have AB within the S as well. So here the substrings AB satisfies the requirement of containing A and B here. You can clearly see this is for the condition minimal match. Minimal match. So I hope this is clear. These are the edge cases that we need to consider. First one is this one was the basic, right? So we have found the substring within the string S, and second one is exact match. We have only one string and we have found the match here. So we were getting the output A. We are getting the output A, right? So third one is insufficient characters. While I say insufficient characters, T has more characters than A. T has more characters than S here. This one. So S is not containing all the characters of T, so the output will be empty string, nothing but insufficient characters. Fourth one was for no match. Here you can clearly see GH is present in T, but none of the characters from T is present in the S. So here we are giving no match. So this is for the no match, and the final one is minimal match. When I say minimal match, here this T consists of A and B, the characters A and B, but S does not consist of S do consist of the characters A and B here. So there is a match and we are getting the output AB, nothing but the condition minimal match. So these are the 5 edge cases that we need to consider here. Let's start writing the code, and I'll explain the code while I write the code. Let's start writing the code. Initially, let's go with the this one. If S is shorter than T, then no valid substring can exist, right? So this we have already seen in the edge case. So I'll just give here S dot length, nothing but if S is shorter than T, there will be no valid string, right? So I can just write in this way, S dot length less than T dot length, then we will return empty string here. This is fine. This is one of the edge cases, and let's make use of the map to store the frequency of the characters in T and in the current window. We have already discussed this one while during the approach, right? I'll just consider here the variable need. I'll just go with the new map here, and also let me go with have, and I'll just create new map for this one as well. So the next step is we have to initialize need with the characters in T and the required counts. How can we do that one? I can just give me a second here. Did I do anything wrong here? No, right? We are just initializing need with the characters in T. So for that one, I'll just make use of the for loop. Let's see of T, and let me make use of the set here to update C. We can just get the value of C from get property, right? So I'll just make use of need.get of C, or it can be 0 as well. So I'll just come here, C I have made use of, right? It can be 0 as well, and the index starts from 0. So I'll just make use of +1 here. This is fine. So next thing is we will be making use of the variables for tracking the window and the result. So we are going with the sliding window, right? So we'll be making use of the variables for tracking window, and also we have to track the result as well. For that also we'll be making use of the variable result. So let me give here left equals, let me initialize left and right to 0 first quickly, and we need the minimum length of the substring, right? So I'll just give here min length. Let me initialize this one to infinity, beginning at the beginning, and let me initialize the start to 0. This is one thing, and also we need the number of unique characters. We need to consider the unique characters in T as well. For that one, what I'll do, I'll just make use of the variable required here. I'll just give here need.size, and let me make use of the formed as well. Form, let me initialize this one to the 0. So here required is nothing but the number of unique characters in T. You don't have to think that much. So next, let's go with the sliding window approach as usual. So I'll just give here while right is less than length of the S. We have discussed this one in the approach. So while right is less than the length of the S, then we will expand the window by including the S of pointer right. So I'll just give here, let's C equals S of right. This is fair. Next, have I have considered, we have to update this one, right? So either it can be C, or we have to get the value of C, right? So I'll just give here have dot get of C. So this one can be just give me a second. Yeah, this one can be either 0 or +1, as the index starts from 0. So this is fine. If the character completes a requirement, then we have we will go with the increment formed. So how can we write that? Simple if condition need dot has of this one C we are considering, right? And also have dot get, we have to get the value of C as usual. If this one is of the same value of need dot get, we are comparing the values, right, of C, then we are incrementing the formed here. Sorry, semicolon. This is fine. Then as usual, we had discussed this one. We will try to shrink the window if it meets all the requirements. I'll just write the simple while condition here. I'll just make use of the while loop here. Let me give formed equals required. If formed equals required, we will check if the window is the smallest so far. How can I check this window is smallest so far? I'll just give here right minus left plus 1 less than min length. So then we will update the minimum length. I'll just give here min length equals right minus left plus 1. Then finally I'll just give here start equals left. This is fine. We are just updating the minimum length. Nothing but we are updating the minimum length as well. This one you can clearly see here. We are updating the minimum length, and this line we are just updating the start index of the result. During the approach I have said we will check if the window is the smallest so far. If the window is the smallest so far, then we will update the minimum length as well as we will update the starting index of the result. This is what we have done here. So the next step is, after doing this, we have to shrink the window by moving the left pointer, right, as usual. So I'll just come here. I'll just give here left character. This one I'll just consider s of left. This is fair, and we have made use of a variable have. Let's update the value, nothing but left char, as well as I'll just go with have dot get left char here. So let me give here left char. This is fine. Finally minus 1. So if shrinking breaks a requirement, we will this time we will be giving we are decrementing the formed. Initially we have incremented the form here. This one you can clearly see. Same thing. If shrinking, this condition was, just give me a second here. If the character completes a requirement, then we were incrementing the formed here. This one, line number 15 here. Then here what we will do in this case, if the shrinking breaks a requirement, then we will be decrementing the formed. Here I can just give need dot has left character we are considering, and we have to get the value of left character lchar, nothing but lchar. And if this is lesser than, let's get the value of lchar, this one lchar. So if this is lesser than this value, then we will be decrementing the formed here. This is fine. So if shrinking breaks a requirement, we have to decrement the formed. Also we have to move the left pointer ahead as well. So I'll just be incrementing the left pointer in this case. So I hope this is fine. Also the next time, let me come out of this one. We have to expand the window by moving the right pointer as well, right? So I'll just come here. Let me increment the right as well. So what will be the final step here? We have to return the minimum window substring or empty string if we have not found any valid substring. So this is simple. I'll just give you a return max length. This one will be infinity. If it is infinity, then we'll go with the empty string, or else we will make use of the slice, and we will start from start and we'll go until start plus max length that we have found. This is fine. Let me format this one once. Let's run code. I hope this works. Line number 26. lchar is not found. C we have considered capital C, I think. Let's see here. Line number 26 right here. Yeah, we have considered a capital C. This one I have given here small c. So let's run the code again. Max len is not defined. Max len, we have defined the max length, right? So yeah, this one has to be minimum length, not the maximum length. Here we are finding min length, right? So sorry, this one min length I have considered, I think. Just give me a second here. Where we have, yeah, min length. This is fine. Yeah, let me run the code again. Again we are getting the, oh, here also I have given max length. Sorry. Yeah, I hope the code works now. So yeah, you can clearly see here the sample test cases are getting accepted. Let me hit the submit button now. So now you can clearly see here all the test cases are getting passed here. So the code works absolutely fine, or the code works absolutely correct. So now let's discuss the time complexity and the space complexity, right? So the approach that we went here is went with here as this one, sliding window, a sliding window, we know that. And what will be the time complexity here? Overall time complexity would be big O of m plus n here. So I'll just give here the time complexity. The overall time complexity would be big O of n. Why the overall time complexity here will be big O of m plus n? Because we know that one thing is constructing the need map takes big O of n here. So here we have made use of the need map here. You can clearly see constructing the need map takes big O of n, where we know that n is nothing but this one, length of the t here. N is nothing but length of the t. In the example, this one, the length of the t here. And expanding and shrinking the window processes each character of at most once. We know that one, right? Taking big O of m. So where we know that m is nothing but the length of the yes. So overall time complexity would be big O of m plus 1. That's what I have written here. So what will be the space complexity? The space complexity will be, overall space complexity would be big O of m plus 1 as well. So why the space complexity here is big O of m plus n? Because need and have, what we have made use of here. Just give me a second here. Yeah, need and have, whatever we have made use of here, need and have maps require space proportional to the size of t and s here, right? So the overall time complexity and the space complexity would be big O of m plus n. So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.